What happens if a modern airbase is destroyed in the first minutes of war? No runways, no safe landings, no air power. For over 70 years, militaries have searched for one solution: aircraft that don't need runways at all. From rocket-launched jets to vertical takeoff fighters and Mach 3 bombers, this is the story of how military aviation tried to break free from the ground. Our story begins in the early Cold War, when nuclear war felt inevitable. The United States Air Force feared that in a nuclear strike, every runway would be wiped out within minutes. Their solution was extreme and dangerous. It was called Project ZELMAL, short for Zero-Length Launch Mat Landing. Instead of runways, modified F-84 Thunderjet fighters were mounted on mobile launch trailers. A massive rocket booster ignited, launching the jet from a complete standstill. Zero runway, zero roll. The launch worked. Landing, however, was the real problem. Aircraft were meant to land on giant inflatable or arresting mats, absorbing the impact without wheels or a runway. In practice, these landings were violent, unpredictable, and often damaged the aircraft. Despite successful launches, the mat landing system proved too unsafe and unreliable. Project ZELMAL was canceled, but it proved one thing clearly: runways were no longer guaranteed in modern warfare. While the U.S. experimented with rockets, the United Kingdom solved the problem a completely different way. Instead of launching jets without runways, they built a jet that didn't need one at all. The result was the Harrier jump jet, the world's first operational VTOL combat aircraft. The Harrier used a single Pegasus turbofan engine with 4 rotating exhaust nozzles. By rotating these nozzles downward, the aircraft could lift itself vertically into the air, hover, and land like a helicopter. This allowed Harriers to operate from small aircraft carriers, amphibious assault ships, forward bases, even damaged or improvised runways. The Harrier proved its value during the Falklands War, where British Harriers dominated air combat despite operating from small ships thousands of miles from home. However, VTOL came at a cost: limited payload, limited fuel, and no stealth. Still, the Harrier proved something revolutionary. Vertical takeoff was not just possible, it was combat effective. The Soviet Union was watching closely. Their answer to the Harrier was the YAKOVLEV Yak-38, NATO-named Forger, the USSR's first operational VTOL aircraft. Unlike the Harrier, the Yak-38 used a 3-engine layout: one main engine for forward flight, 2 vertical lift engines behind the cockpit. This allowed vertical takeoff from Kiev-class aircraft carriers, giving the Soviet Navy its first taste of VTOL aviation. But the design had serious flaws. The lift engines were dead weight during normal flight, reducing range, payload, and reliability. The Yak-38 had a high accident rate, short combat radius, and limited performance. Despite this, the Yak-38 was a crucial learning step. It provided Soviet engineers with VTOL experience that later influenced the Yak-141, a design that quietly contributed ideas to future Western VTOL aircraft. At the same time, the United States explored a completely different strategy. Instead of avoiding runways, what if aircraft could simply outrun every threat? That idea produced one of the most extreme aircraft ever built, the North American XB-70 Valkyrie. Designed to fly at Mach 3 plus above 70,000 feet, the XB-70 relied on speed and altitude for survival. Its unique folding wingtips used compression lift to improve efficiency at supersonic speeds. This bomber was faster than most missiles of its era, but technology caught up quickly. Advanced surface-to-air missiles and intercontinental ballistic missiles made high-altitude bombers less relevant. The XB-70 program was canceled after only 2 prototypes, yet its legacy lived on, providing critical research for aircraft like the SR-71 Blackbird and modern high-speed aerodynamics. Decades later, all these ideas finally converged into one aircraft, the F-35B Lightning II. It is the world's first stealth supersonic VTOL fighter. Unlike earlier designs, the F-35B uses the Rolls-Royce lift system, combining a shaft-driven lift fan behind the cockpit, a 3-bearing swivel module that redirects exhaust downward, wing-mounted roll posts for balance. During its first successful vertical takeoff tests, the F-35B proved something once thought impossible. Stealth, supersonic speed, advanced sensors, and vertical landing all in one aircraft. Today, the F-35B operates from amphibious assault ships, short runways, and forward bases, making it one of the most flexible combat aircraft ever built. From rocket-launched fighters crashing onto inflatable mats, to jets hovering over ships, to stealth aircraft lifting straight into the sky, this isn't just aviation history. It's the story of how air power learned to survive when runways disappear. In future wars, the first targets won't be cities or ships, they'll be air bases. And the aircraft that can take off from anywhere will control everything. This is only the beginning. On Insider Entirety, we'll continue uncovering the hidden technologies, secret experiments, and next-generation weapons shaping the future of warfare. If you want to understand how tomorrow's battles will be fought, subscribe, stay curious, and stay ahead.